and then getting this information. It has to be on your fingertips to be able to then you're running your production in a most collaborative manner. So these are some of the things that we have to offer to the market, and these have been extremely aided by the current technologies that are available. Okay, but Aspentech on its own, with the last 40 years of experience, this is what we bring to the table: an optimization of not just the process, but the surrounding technologies, the surrounding infrastructure, the value chain. This is what we bring to the table. Okay. So in driving, to summarize, to driving operational excellence, you want to check availability is most important. Performance, of course, it is. But I'm going to focus, as I said before, on what are you doing to make, to increase your availability. So, unplanned downtime. Okay, missed opportunity. So that is a there could be missed opportunities because of that. Performance. So operating inefficiencies, removing bottlenecks, these are the regular things that we do in the plant. But what are we doing about demand variability, supply chain disruptions? Okay, we might have some master data on our supply chain or our demand forecasting, but this keeps changing and it will always be outdated. It is with the sales team, but not with the production guys, that they are able to collaborate most effectively, right? And these are the tools that we want to put in your hands. I'll quickly digress for a minute. While I want to focus today on reliability and specifically data-driven failure prediction and production optimization, there are so many other technologies that it is in digital transformation. And you can see some of the few years. You want to focus on sustainability, operator performance, even your operator performance. If he is flooded with alarms, for example, he is distracted and he is not performing efficiently. So there are solutions how to avoid, how your operator can only get the alarms that are important. He's not flooded. It is no different from you having so many notifications on your phone and you're not paying attention. Okay, so how do you make the operator efficient? How do you make the operator? So these are some technologies, and one can find, we can work with you, what is most important, which is the initiative in this particular slide that is most important to you, to give you the highest business returns. What today is the most important is something that we can attend to. So digital transformation has to be a journey that will take you from, so currently if you see, a lot of the plants could be manual. Some are automated, so there is isolated improvement within those silos. Once you get to the automation, the level 3 that you see here, once you get to the automation, you do some kind of optimization in the processes so that you are squeezing the maximum out of your process. But what we want, and most industries are currently here, especially chemical industries are here. The refining, the oil and gas, and they are probably between 3 and 4 and trying to get at 4. But chemical industry, we see from our experience, is predominantly at level 3. And what we want to bring to you is the AI, ML based softwares which can improve the current algorithms of optimization in actually additionally learning while you are also learning as a plant operator, and aid you in demand forecasting, in all of the future planning that can possibly happen. Okay, and finally, the new business model, the vision that we at Emerson have is your employees, if you're a chemical plant operator, your employees will not work today on today's problem. They will always forecast 6 months ahead what's going to happen based on the demand projection, based on planning their supply chain, and they already know what's going to happen 3 months down the line, 6 months down the line. Okay, and today's job will be a manual job that the computer is taking care of. Okay, it is okay, some minimal assistance is there. It is not autonomous, but that is how we want to free the manpower that they can focus on your productivity. So I was talking about reliability. So many a times, you like the example of drive that I gave, the car drive. You're setting out, but you may not be sure if something is going to fail. What if our softwares gave you that intelligence, the predictive intelligence, that any of your equipment? So what we have are three kinds of agents. The failure agent, a rule-based agent, and an anomaly agent. Okay, so a rule-based agent is first principle based on physics principles. So a pump is going to work in a certain manner. A compressor is going to work with the physics principles. Okay, a heat exchanger or a distillation column, all of them are going to follow some rules of physics or chemistry. Okay, and that is known. Okay, when you add to that data-driven stuff, which is you apply the intelligence from your history, from your 1 year, 2 year, 3 years of history, and that is something you already have in your control systems, but you never put your mind to it. It is those trends are there, right? But what we are doing is we are building models from that historical data, applying that to first principles. So you have both the advantages of looking at the first principle model output and the data-driven model output, and look at where your process is going. When you apply this to assets, okay, individual assets are very easy. Okay, so a pump, a compressor, so these are known assets. So like that, in the library we have around 500 assets, which will cover most of the industry processes. Okay, when you combine these first principle models and move up, come at the plant level, then you are talking about plant reliability. So these are not just asset fixed. Okay, you know what your plant reliability numbers would be, what your availability numbers will be. The impact on the operations is that you have reduction in up to 80%, sometimes even 98% unplanned downtime. This is one of the multinational chemical manufacturers. The numbers that you see on the right hand side are from a US MNC. Okay, and all this is possible because of advanced warning, and of course it translates into lower maintenance cost. Okay, I'll give you some example of. So this is a pulp and paper manufacturer, whereas this is from Brazil, and they are the largest pulp and paper manufacturer in the world. And as you can see, why I chose this example. So there are several examples. If you visit our website, you will see several examples. This is a customer testimonial. Several examples. Why I chose this? Like in a paper mill, of course, there's a chemical process. Starting with the pulping of wood, then you come to the mechanical parts. Then you have the paper machine. So there are known equipment, known process equipment such as the pump, compressor, etc. But there are also those that can't be modeled. For example, a paper machine with a lot of rollers, you cannot model that, right? Okay, so in that, because every roller will behave differently, sometimes when you replace the parts, one roller is from one OEM and another roller is from another OEM, and these things are part of the paper industry. So how do you determine that something is going to fail? It can only be data driven in those cases, right? So there's a good mix and match of both these data-driven models, algorithms, and first principle based, that you are able to arrive at the right mix of the right data that you want to have your plant most reliable. Okay, this is another example of a multinational company. Okay, and this is diphenyl methane manufacturer, and as you can see, 80% reduction in downtime. Okay, so So up to 80% reduction in downtime. So, I mean, the kind of request that we are getting from industry is they don't want to attend to an equipment like a heat exchanger. They don't want to attend to it. They say, I want to reduce my downtime by 20%. By that's the beginning, of course. And how far they can go is really up to us, how far you can squeeze that, okay? So there is, let me give you an example. So one chemical company had around 35 days of downtime in a year because of ad hoc failures. And the beginning, they just wanted 20% reduction in that, which means what? From 35 you come to 28. Okay, so we're getting there. Definitely over 1, 2, 3 years, you will squeeze much more, probably faster, if you are able to zero in on the problem. But earlier, these systems were not available, okay, and now they are, and we learned all of that. And all this is happening only because of collaboration. The equipment, we are not equipment manufacturers. We don't manufacture pumps or we don't manufacture any process equipment. The OEM knows better than us. Okay, we have those OEM libraries, OEM modules, but finally, how to extract this data is again our job. How to make those algorithms. So some of these softwares, they run up to 14, 15 algorithms simultaneously to be able to arrive at these this kind of results from that you can gain from AI and ML activities. Yeah. Let me quickly, so that was reliability. Let me quickly move to production optimization. So as I said, it is not just enough that you're running a very efficient kitchen. You got to, you got to look at the demand. You got to be in sync with your sales team, with what the market is going to ask you, maybe in a month, 2 months, 3 months, 6 months, and a year. Okay, and that is how, if you plan that much, it is definitely in this times it's not going to go exactly as planned, probably. But not having a plan is also, we all know, is not the right thing for business. In that also, when you're coming to the to the last day or to the last whatever schedule is planned, you can tweak those, because you have everything on your fingertips that you're able to control. Okay, so we are not just looking at the whole integrated supply chain. Okay, and there are several softwares that we have at AspenTech. Okay, starting with supplier, raw materials, manufacturing, of course, that we have been for so many years now, warehouse, distribution, all of this. And some of these examples that you can see, Momentive, so these are all American MNCs. Okay, and you can see the kind of results that they have produced. So for example, Momentive is a performance chemical company, a silicon manufacturer. Okay, and they were able to reduce their overall value chain optimization by 20 points. Altria is a tobacco products company. Okay, 50% reduction in on-site inventory. So now, when you have these kind of results, what basically you're also helping your company, your enterprise, with the total working capital. It's not just an optimization that is happening, it is straight away contributing to your bottom line. We have a request. So earlier, it is also a learning for us at Emerson. Earlier, we used to always get an inquiry for a particular instrument or a particular control system that we want to, they know we can supply. But now they say, no, I want, when we implement your system, next year, or maybe 2 years down the line, my EBITDA should improve by 1%. And these are the kind of requirements that we are getting. Okay. So this is up to you, each one of you, in your own organization, in your own enterprise. What is it that you want to contribute? What are your priorities? And you know this best. Okay, so it is just, I'll not go through this whole chart. So between the ERP system, enterprise resource planning, and the automation layer, which is, I've started calling this the brick and mortar. You have so many things, prescriptive maintenance. So you already know where you are in terms of reliability of equipment. There's not going to be a shock. There's not going to be a surprise that you've taken up production and suddenly there is a unplanned shutdown. It's not going to happen because you have the right systems in place. Plan and schedule, control and optimize. We're already there for many. I'm not going to talk about it. Monitor and execute. Okay, and all of these are rigorously modeled. So we have the process models for this. We call it digital twin when it's in the process side. Okay, on the on the workflow side, we model the workflows. So as you plan your schedule day to day, medium term, and then the long term, you can plan up to 2 years and what have you. So again, the first problem that I pointed out, whether you are running your plant up to constraint limits. I'll give you some examples on what some of our customers have done. Okay, and this is just one example of a software. This is the Aspen Plant Scheduler. You can see this can be applied to a continuous process, a semi-continuous, or a batch process also. How do you get from a continuous process to a batch process? So finally, your purchase order is going to be a batch, right, that the customer buys. How do you correlate that data? How do you know which order was profitable, which was not? Because it's all continuous, you cannot know. How do you mine that data? How do you serve that customer which pays you well? Okay, or even when your sales team is negotiating with a customer, for example, and obviously negotiations are always tough. You can always remind your customer that so and so order I picked up, I have delivered to you even when I faced losses. And this data probably currently even your production team may not have, because they don't know when they produced at what prices they picked the raw material. You can see this chart. This is very easy. You can correlate everything. And this is straight. You have this data today in your plant. Only you're not using it. You're not mining it. Okay. So many benefits. I mean, I'm just trying to make it optimally contribute to the bottom line, but including emissions projection. So many benefits there are. So I'll give the example of Momentive. Okay, so they improved the on-time in full performance by 20 points. So this is a polysilicon silicon manufacturer. Okay, and these are all customer testimonials. Between supply chain, they decreased by 10 days, which is 40%, or inventory by 30%. But overall, they were able to improve their operations by 20 points. This Altria, as I mentioned before, is a tobacco product company, an extremely highly regulated industry. And again, in this, they were earlier they were all doing this on a spreadsheet, on an Excel sheet. So when you do it so much manually, there will be flawed decisions. Okay, you will buy something and it will lie up in the inventory till it is used. You're not optimizing it. So again, these will definitely, when you have this knowledge, when you have it on your fingertips, this will help you. Okay. So Nemak is aluminum automotive chassis it makes. Again, 98% reduction in premium freight. What is premium freight? Okay. Sometimes to avoid LD, okay, we produce till the last minute and there's a truck waiting outside and you ship it out. Okay. So that is premium freight. When you are planned so well, you don't have to pay premium freight to your transporter. From that itself, the 98% reduction came in. You can imagine the kind of savings that are possible. Okay, Isle block is a it's a lubrication based company, and in that, apart from the base oil, there are so many additives, so many so many raw materials to be packed. And in this, there's a huge breakthrough in planning and scheduling. Westlake, so this is a polyethylene manufacturer. Okay. Here also you can see, there's a schedule creation down reduced by 95%. So huge, and these things happen over a period of maybe 2 to 3 years, but it can happen faster. But we take small targets, probably 10%, 20%, and that's where we start, and that is how we can keep improving. So finally, in summary, there's a lot to do. There is tremendous opportunity, tremendous scope in process optimization, production optimization, to provide significant improvement in margins. Okay, and all these are vertically aligned systems, vertically integrated solutions. Okay, right, starting with the control system and all of the layers that you can attend to. What we propose is a digitalization workshop with your enterprise, your company, and then we can have an adoption plan. So that's it from me, gentlemen. I think.
Thank you, John. I'm also working in the process industry for the last 43 years, and I can say for sure that since they have started in control system for 40 years, so I have been also associated with Emerson for 40 years, my earlier companies and present companies. You know that the entire Haldia unit is with complete Emerson controls. So I can definitely say for sure that your systems are very good and they're working. And
thank you, sir. Thank you
so
much
for your efficiencies
for
and
that
everything.
kind word. Yeah.
Thank you. So please stay put. We'll have some recitations and awards for you.
Yeah.
Murtadaji, if you can please come in.
We have also reduced downtime from 25 to 13 days, and that to ammonia production.
Okay. I'll make it.
Certificates no, it's not yet. You still have to carry it on.
Yeah.
So you talked about twins, right? So what I see in industry that there are critical and non-critical equipment.
Correct.
So all critical equipment now the manufacturer itself started coming up with the twins, right?
Correct.
And then there's a confidentiality comes into a play, right? So when you want to integrate all those assets into one, that's something which I see as a barrier.
Correct.
How do you see that as a kind of when you want to integrate it? What kind of challenges you see as a immersion? I would say, which I just wanted to understand that.
Okay, so see, the OEM typically would have confidentiality or non-disclosure agreements and those things. But the data, if you're running a production plant, if you're the end user, the data is owned by you, right?
Yeah.
So we are accessing the data and mining the data to be able to find the intelligence as to what's wrong with it. So for example, if I am not giving you my test report, my medical test report, you can probably still detect from other parameters, what my health condition is. And that is my work in that. And that definitely, I don't think it can be covered under any NDA or any confidentiality, at least I have not come across.
Because that data again goes to a cloud of the OEM, which is again connected to the entire world equipment, right? Just to try and bring those intelligence back to you. Right?
Correct.
So I see some challenges what we have faced currently.
So those, I think, what you're trying to say is that is for the equipment design. But as a process, as a production output, that is what matters to the user, the owner of this plant. And we are working with the owner, so it doesn't conflict as to whatever the business model of the OEM might be. So, thanks.
Thank you, John. Moving on, we have Mr. Devabrata Ghosh from Olicon Textiles.
Good morning, distinguished.
I'll just, 1 second, I'll just take a few minutes to introduce you. Devabrata Ghosh is giving a CTS Speaker Award on behalf of CSIR NERI Chemcon Distinguished Speaker. He is a He's a postgraduate in Fibers and Polymer Science and Textile Engineering from IIT Delhi. He is working with Barmag since 1993, which now belongs to the Olicon Group as Vice President and Director Sales, and is responsible for India, Bangladesh, Nepal, and Sri Lanka. The man-made fiber segment, with its brand Olicon Barmag, Olicon New Mag, and Olicon Non-Oven, is a world market leader for systems used in the manufacture of man-made fibers, synthetic textile fibers, which are processed into functional clothing, carpets, furnishing, and increasingly into the technical textiles for airbags, safety belts, as well as into geotextiles for road construction and other industrial applications. Mr. Ghosh, the stage is for you.
Good morning, everyone, the distinguished audience and respected speakers. It gives me great pleasure to be invited here from the Chemcon organization, and special thanks to Mr. Vishwanath Chatterjee for giving us this opportunity to present the solutions we bring for sustainability and recycling, especially in the field of textiles and man-made fiber. So I have structured my presentation in 3 parts. First, I will present the company Olicon Man-Made Fiber, which is now known as Olicon Polymer Processing Solutions. Then I will talk about BBE. This is our joint venture, Barmag Bruckner Engineering. We have innovative technology, which is for recycling, mainly the mechanical recycling from bottle to bottle, from textile to textiles, as well as from bottle to textiles. All these 3 solutions we provide. And then I will show 2 videos which describes the entire process of how this recycling happen. It will be definitely very good and interesting for the students as well as the people from the industry. They will see actually in industry, in process, how this machine and technology runs. So this is Olicon Barmag. This is our centenary year. This 1922, this company was founded in Wuppertal near Düsseldorf as a component manufacturer for viscose filament yarn. Back to 1922, there was no synthetic fiber discovered that time. Nylon was discovered in 1942 and polyester came in the 50s. So Barmag started as a component manufacturer for viscose filament, which is regenerated cellulose, in 1922. And gradually it became the world's #1 company in the field of synthetic fiber. With the inventions of polyester and nylon, we developed new technologies, machines, components, and we have hundreds of patents throughout the world, all these years. And this is our 100-year celebrations. In last 10th December in Delhi, we made a big celebration. Also in Mumbai, we had big celebrations. All over world, all the Barmac subsidiaries, agents, customers are celebrating our 100 years. The reason for the success of this 100 years and to remain stable and to grow continuously in this field is, of course, because of the innovation. And we believe that innovation starts with creativity. This innovation and creativity is very much in the DNA of this German company. And all our customers recognize that and acknowledge that. So innovation starts with creativity, and that is the reason for our success for the 100 years. This we strongly believe. So now Barmac belongs to Oerlikon. Oerlikon is a Swiss global high-tech engineering group with unique competence in advanced materials, surface solutions, and material processings. The divisions which I represent is polymer processing solutions, which is also the man-made fiber divisions, almost close to 1 billion Swiss franc turnover, and has subsidiaries throughout the world. And our one of the main philosophy is we supply the complete technology from melt to yarn, fibers to non-ovens, and we supply clean technology and we build smart factory. This is the only company in the world who can give you the polymerization plant, and right from the CP polymerization plant up to 5 synthetic fiber, the filament, POY, FDY, DTY, polyester staple fiber, non-ovens, everything can be supplied from one group. And this is our biggest advantage, why our customers worldwide prefer our technology. So this is Oerlikon. It serves the need for better functional fibers. We are present in the field of infrastructures like geotextiles, flooring, that is bulk continuous filament, packaging for bottle-to-bottle PET bottle packaging, then IDY, industrial yarn, and of course the main product is for the apparels and the functional wear. So this is our engineered plant solutions as a one-stop service, what I just explained, that right from polymerization plant to spinning to up to DTY, we supply the complete full range of equipments as well as the engineering part, and we can also build the plant on turnkey basis, on EPCM. So this is Oerlikon. We are present in the middle of the polyester chains. Our feed material is PTA and MEG. Then the entire thing from the CP, polymerization, the spinning, and of yarn as well as the bottle grade chips we can make through our Oerlikon technology. So these are the different type of products what we can give from the Oerlikon side, and we are Industry 4.0 ready. And now I come to our core subject today, that is the recycling. Now, why recycling is so important for Oerlikon and why we are bringing this innovative technology. So almost 68 million tons of polyester is produced throughout the world. There is a figure in 2019. Out of this 68 million ton, almost 50%, there is 35 million tons of synthetic polyester fiber is produced out of Oerlikon machine. Now, textile industry as a whole, the textile industry, it causes a lot of pollution. Textile industry, including the synthetic fiber industry, is responsible for 10% of CO2 emissions throughout the world. It is more than the pollutions generated by international flights and maritime shippings. So therefore, we have to find solutions to minimize this, and we have to provide solutions how we do recycling of the polymer to help the environment. One interesting figure for all of you is in 2019, all the clothes bought by only the European Union populations, each person was responsible for 654 kg of carbon dioxide generation, CO2 generation. So you can imagine the person, for one person, the amount of clothes we produce or we wear or we buy in 1 year, we are generating 600 kg of carbon dioxide. Another, one more reason is that today the garments are much more cheaper compared to what it was 30 years back. So for example, a lady for an evening gown, what the lady used to, I mean, for the same polyester gown, 30 years back, what was the cost? And what is the cost today is only 20%. So therefore, affordability has gone up. So people are using and buying more and more garments. And we have to find solutions how to do the recycling of this to save the environment. And in this entire textile process, if we do the analysis, spinning process, the yarn making is responsible for 38% of this CO2 emissions. The preparation process, that is weaving of clothes, sizing, weaving, and the finishing of clothes, that is 33%. And 29% CO2 emissions come from garmenting, retailing, and the use of clothes, the washing of clothes. So therefore, we have to come with innovative solutions. And these are the different input material from the bottle flakes, for the fiber and film waste which is generated during the spinning. Also, this agglomerate, the popcorns which comes in the spinning process, and then the rPET granulate, master batch, and virgin we all can process and provide. These are the different technology what we give. We have Oerlikon Barmac homogenizer, the PET recycling line. We have our joint venture organizations from BBE, that is Barmac Bruckner Engineering. We provide from bottle flakes to, again, bottle or bottle flakes to textiles. We also have this vacuum fill visco, this BBE PET recycling lines, this rPET spinning lines, and rPET BCF. Also this rPET we can make to carpet yarn. This is BCF means bulk continuous filament, that is carpet yarn. We also have technology to convert this recycled PET to spunbond lines for geotextiles and bitumen roofing substrate. So this is the recycling product applications area. This is home furnishing, functional wares, carpet, geotextiles. This is the different type of yarn. Now I show you our BBE part. This is BBE. BBE means Barmac Bruckner Engineering. This is a joint venture company for Barmac and the Bruckner Group of Germany. This Oerlikon Barmac is having 50% share and Bruckner is having 50%. Bruckner is very well known in the world for the film lines. So Barmac and Bruckner, they have formed this joint venture company called BBE, and we manufacture after BBE the extruders for spinning and film lines, melt filtrations, melt modifications, this 3D mixer. 3D means this three-dimensionally dynamic mixers for dosing or master batch. And also we provide compact melt spinning line variofill and the recycling, which we call vacuofill. Later on, I will show you interesting video of this variofill and vacuofill, so you will understand what do you mean by this terminology. So in BBE, our product portfolio, we start with the extruders because we have to first process for the recycling. We used to melt the bottle flakes or melt the textile waste and spinning waste. So it starts with the extruder, and we have the complete range of from 30 to 360 millimeter of extruder screw diameter and throughput from 3 kg up to 6 tons per hour. You can see in these figures. And the products are the film lines, and for spinning lines, the BOPA, BOPT, POY, FDY, all these terminologies, textile terminologies, all of you may be knowing this. So the first step is the extrusion, because we provide mechanical recycling and not chemical recycling. Now if you ask me what is the difference between a chemical recycling and mechanical recycling, chemical recycling basically alters the molecular structure, the rheology of the polymer, but in mechanical recycling it doesn't happen. And chemical recycling is more toxic, not environment friendly, and also it is much more energy intensive. So for environment friendly process, we promote this mechanical recycling, the physico-mechanical recycling process. This process first starts with the melting of these bottle flakes or this waste or the textile waste, and then the next step with the extruder, then the next step comes in the polymer filtration, because we have to filter and remove the impurities. We have both continuous, discontinuous filtration system, wide range of filter, lot of informations are available in our website. Also, my colleague, Mr. Sudipto Mandal is here. We have also having a booth here. You can get further information from Mr. Mandal also. Then we have this compact spinning line. We call it variofill. It can be a 2-positions machines. It can be 4-positions machine. Very interesting machines. It's a plug and play technology. It is one of the most compact spinning line what we can give to the market for the processing of rPET flakes, the chips directly to the yarn. Up to 8 positions per line we can offer, the variofill line. We have in BBE several decades of competence combined, and we have 400 polymer melt filters we have supplied, compact spinning line more than 55 we have supplied, and of course 17,000 extrusion systems or extruders are in operations. So this is vacuofill, and the requirements for the filament yarn spinning, if you are doing this recycling of the polyester, of the flakes and waste, of course the most important part is to maintain the melt homogeneity so that you can get a constant and yarn parameters, highest DTY, this is the textured yarn quality, and highest dyeing uniformity. And importance of filtration is very, very important for the recycling process, because we have to remove the gels, and we have to minimize the filament and yarn breaks during spinning process so that the efficiency doesn't come down, and we have to produce also the highest yarn quality. And the gels, particles, and all these things are to be filtered. So challenges for thermomechanical fiber to fiber recycling processes, the different shapes and sizes of this waste, and it is contaminated with spinning oil, then the fluctuation of the viscosity and moisture levels, and the dirt we have to remove. So there are a lot of challenges, but our technology can take care of all these challenges. And post-consumer recycling means this is mainly the t-shirts. If it is 100% say polyester clothes or polyester t-shirts, we can also tear it and we can process this. So the solution provided by BB is the first step is the reduction of the size when it is a textile process, textile waste. Then we have to do the pre-dyeing and the feeding, and the light drying to reduce the hydrological degradation, and compact feeding we have to do through this process. And dosing of materials like PET bottle flakes also we can do it in this machine. Then in the extruder, we have to do the degassing of the system, degassing extruder, we call it, of volatiles. We have to remove the volatiles item at an early stage to provide a homogeneous melt for the downstream spinning. So degassing, and then the coarse filtration, we call the screen filter. So it is the first stage of filtration, that is the coarse filtration happens. After that, we provide this visco. This is for the viscosity adjustment, because it is a liquid state polycondensation process where we increase the viscosity by 0.1%, 0.1 dl per gram. So this is required, especially when you are doing this bottle or textiles, or when you are melting it in the extruder, the viscosity will go down. So we have to increase the viscosity, and for this viscosity adjustment and increasing of the viscosity in the melt phase or liquid phase, we call this liquid state polycondensation that happens. Then it is the video you can see how it works. Yeah, this is how this visco works. and how in this visco we have to lift up the IV intrinsic viscosity, as I said, by 0.1. And then the fine filtration happens. After the fine filtration, there is a large area filtration, it's a continuous vertical filter. I just quickly go through these components of the spinning lines. These are the large area, long life, large area spin pack. And this is how the machine looks like, inline fiber to fiber, when we are doing this fiber to fiber recycling. These are the different components. We start from the dryer, then the vacuum dryer, then cutting, extruder feeding, then the melt pump is there, then visco, then the online viscometer, then again the melt pump, then there's a large area filtration, the 3LF filtration which comes. Then we also provide the 3DD, this three-dimensional dynamic mixer, the dosing system. Then we have this strand pelletizer, then watering pelletizer, and then underwater pelletizer. And then finally, this is how this machine, the complete system works. This is the advantage of our system is the technology what we provide for recycling, and our compact spinning is lower energy consumptions, fewer materials, best color values, less material degradations, less labor intensive, and of course, investment is minimized as well as the space minimization. Less space is required with this compact machine. So this is fiber to fiber recycling of high to high end filament yarn. These are certain quality parameters. And we have references of this technology throughout the world. You can see how many machines we have supplied, and this is all a proven technology in the world. So this is all from BBE. I now show you one video how this variofill machines works. This is basically the compact spinning machine. This video describes the complete spinning process. This is the extruder. This is the metering pump, also manufactured by Barmac. After the metering, then the melt is pushed through the spinning heads to the spin packs. This is the large area, long life filtration happening in the spin pack itself. This is the quenching system to solidify the melt to yarn, and actually the yarn formation happens in this quenching system. These are the goddess for stretching the yarn to make FDY or IDY, and we use the high frequency, the electrical heating system. This is the real practical system in the industry, how the yarn is produced from the mill, from the chips, whether it is virgin or from the recycled yarn, both. That is the Barmag wings winder. The most high-tech part of the machine is this winders and this traverse system. You can see how beautifully the packages, the yarn packages are built up. These are all highly engineered equipment and precise equipment. This is how the yarn package gradually build up. This is fully automatic winder. Automatic bobbin change happens with 99% safety. Okay. So this is all from my side. The message is that we are world leader for the recycling technology, mainly for the mechanical recycling, and we provide solution from bottle to bottle recycling, from flakes to fiber and filament. We also have technology for textile to textile now. We demonstrated these machines in the last K show in the Düsseldorf. And we can also use this recycled chips, to convert it to BCF, the carpet yarn, as well as for geotextiles and geomembranes. And we are continuously doing R&D on this to improve this process, and definitely in future we will come out with more innovative technology. So that's all from my side. Thank you.
Thank you, Mr. Ghosh. It was really nice to know about the recycling part of the polyester. So I'll request past President Vinayji to please come up on stage.
You are here. Souvenirs, which is going to be. Thank you, all the best, and very nice lectures. Sir.
The next speaker, Mr. Chirag Soni of Eastman Chemical. he is getting CSIR NCL's Professor K. Venkataraman Chemcon Distinguished Speaker Award. I would request Mr. Soni to come up on stage.
Good morning. Good morning to all of you. And thank you, Chemcon, for giving us this opportunity. And I must say that Chattopadhyay Sahab, we are here committed to continue this legacy year over year. So that's a promise which I'm going to make it here today.
Please introduce. I'm not getting your page here.
Oh, that's fine. So myself, Chirag. I work for a... okay.
Let me. Yeah, the 77. No. '67. Mr. Chirag Soni, yeah, he is the Technical Service and Sales Manager for Asia Pacific SFE Division of Heat Transfer Fluid Terminal, Malotherm and other products of Eastman Chemical Company, USA. Chirag holds mechanical engineering degree along with Masters of Business Administration from SP Jain University, Mumbai. In addition, he is passionate about abundant energy saving and renewable energy opportunities in industry, led him being certified energy manager by Bureau of Energy Efficiency. His learning appetite did not stop here. Later, he followed holding a piping engineering certificate from IIT Mumbai. If life permits, he has his desire to follow PhD in sustainability. That's a good one, good goal.
Yeah,
so
that's
Chirag,
a desire.
please, you can start your presentation.
Thank you, Chattopadhyay Sahab. So once again, good morning, and thank you, Chemcon, for giving this opportunity. I must say that we are hereby committed to continue this opportunity year over year, provided Chemcon permits. So thank you so much once again. Let me introduce, first of all, who we are as an Eastman. We are a global specialty chemicals company. We are Fortune 500 and one of the top 10 specialty chemicals companies in the US. We are a $10 billion organization, and we have around 14,000 employees across the world, and we have our operations more than 100 countries so far. There's a lot to talk about Eastman, but I guess today I see a lot of interest towards recycling, and I guess Mr. Ghosh touched upon two important aspects of recycling. One, which is the mechanical recycling, and second is the chemical recycling, right? So mechanical recycling has been historically present in India and globally. And there are many plants today, in fact, in India, where the PET bottles is being mechanically recycled and the fibers are being produced. Certainly on a Barmag and Barmag machines, I must say that. Alternatively, there's a chemical recycling technology. What we do, having a chemical recycling technology, is we take the PET flake and we convert them to a feedstock. So it's 100% chemical recycling where we are going to convert back PET into a two major feedstock, DMT and MEG back. And the same will be filtered and reused as a virgin product. So just to talk about, we have announced two important technology publicly. We call it CRT. Yesterday, people talked about the plastics. And there's a family of plastics which has like, you can look at it 1, 2, 3, 4, 5, 6, and 7. And CRT, what it does is, we will have all mix of plastics. We are going to recycle to a carbon level, and those carbon level will be reused into a feedstock. Okay, manufacturing of the feedstocks. And we have a polyester renewable technology, we call it PRT. We already have a glycolysis plant running in the US. We are moving ahead a step forward, which is methanolysis technology. And having this technology will have two major feedstock of the polyester industry, which is DMT and MEG, and the same will be reused. We are probably would be the number one having plant operational of chemical recycling PET by next year, and the plant is currently under constructions in US at our headquarters, Kingsport. I'm not a subject matter expert of this PET and CRT, but I am here to talk about, I guess, hot oil heater, which is one of the integral part, I must say, for the chemical industries, because we talked a lot about process and reactions, right? And all those process and reactions would need a process heat. And that process heat typically would have two major medium being used. One is a steam, and second probably would be the hot oil. There are many, but I would say majority of this, which is steam and hot oil as a heating medium. I'll talk about hot oil because steam is something which is regulated body, where you have the boiler code, boiler proficiency people, the competent people, designs are vetted, but hot oil system is something which is not regulated so far. There is no policy which is being framed so far as hot oil heater is concerned and the operation is concerned, but I would say good to have those in the coming years. This is what kind of product portfolio we have. We have around 14 various grades of heat transfer fluid, which serves a temperature range from minus 115 to positive 400 degrees C. And so in a way, you can have the product of your choice, which can meet your process requirement, be it cooling side or be it heating side. And this hot oil is being widely used in many of the applications like hydrocarbon processing, refinery, oil and gas. Of course, polyester is one of the major segments to it. Then there are food and beverages, heat processing, and I guess very important is the renewable energy, which is solar heating system. I would say solar thermal power plant as well. A lot of concentrated solar power plant where these hot oils are being heated using a sun rays up to as high as 395 degrees C. Then they are taken into the heat exchangers, steam is being produced, and that steam operates the turbine and the power is being produced, right? The many of such CSP plants exist in the world. They are they exist since 1985, I believe, But yes, it's an expensive technology over PV, and so we don't see that is kind of moving very fast in the world. Moving forward, now we are more towards the heat transfer fluid system. So look at the kind of life cycle of heat transfer system, right? We have, first of all, the plant wherein we have system design. We have designed the hot oil systems taking some considerations of what product are we going to use, how are we going to use, what is the ESH requirement of that product, and so on. Then what we do is we buy the product, we fill it. We do a so-called the curing process, what industry I would say considers is basically a moisture removal process, because you have a new system, and as long as you heated it up, there will be an elongations of the piping, though it is being well stress analyzed, but there will be some elasticity time required to make sure that that operates safely and without leakage. Then you continue to operate that system. Of course, you'll have to follow certain maintenance process like leakage as well as monitoring systems. Then, of course, there is a life, right? Every product has certain life, and at particular age, we are either to replace or to dilute until the next shutdown comes to make sure that it operates efficiently. And of course, when the product is reaching to an end of service life, you'll have to either replace it, refill it, and move forward. So that's a kind of life cycle of this heat transfer fluid systems, right? And I guess during this Chemcon, what I could see a theme is the sustainability, right? And I believe the simplest way to manage the sustainability is how do we extend the service life of the product. We talked a lot about disposing and recycling, but I would say if I would extend the service life of the product, that too would be one of the important element I would say one needs to look into as a sustainability. What happens when this fluid reaches to the end of service life, or there is a premature degradation of the product, right? Of course, you see on your right, there's a pipe, and these products are typically degraded into a carbonous deposits. We call it sludge, and that sludge would accumulate in the pipeline, resulting a reduction of the heat transfer coefficient, and so you are not going to have the required process heat, and so entire operations becomes inefficient. You consume more energy to produce the same heat what you needed, and so of course fuel, and I would say energy is the utmost part of, I would say, is the industry which helps keeping the cost as low as possible. And there is a chances of mechanical hazard, right? Because there's a pressure, and if there are blockage, may result into either a leakage or there could be a fatal failure of equipment. So in a nutshell, your equipment life is reduced, your product life is reduced, and of course you are going to compromise to the safety, right? So how are we going to make sure that this product works well and it has an adequate service life of the product life? So the three important elements which I'm going to talk about, which is probably one as an engineer needs to consider. One is the selections of the chemistry what you choose. Whatever the product you choose, there is a chemistry into it, and understand that how to select that chemistry with respect to a stability of the product, what it is going to deliver. Second is the system design. We'll little talk about it, and of course an operation and maintenance is something which we as an engineer have to be careful with. So there are certain control systems. I guess Immersion talked a lot about how to make sure that the controls are well in place, because that's also very important to operate it safely and efficiently. And there is a monitoring system which we'll talk about, though there are regulations, but I see hardly such regulations are followed by an industry. So selection of chemistry, I would say, is the first part. I mean, you can see that you have a choice. Whenever you select a hot oil systems or a heating systems, there are many hot oils or so-called thermic fluids available in the market, right? So there's a variety of chemistries available. Look at these chemistries on your left and move from left, I would say, bottom to the top. You see the aromatic contents are increasing in a layman language. I know there are a lot of chemical engineers present, they know much better than us, and as you bring more aromatic content into it, the stability of the product increases. You can see there are chemistries like DPDPO at the top, which can withstand a 400 degrees C temperatures. And in my 16, 17 years of working life with Eastman, I have never ever seen anybody who has replaced this system, right? It has a super service life, I would say near to 30 years and plus. Then there are other chemistries we call as partially hydrogenated terphenyl, which is widely being used in the polyester industries, having a maximum bulk temperature requirement 345 degrees C with the operating life more than 22 years. There are DBT chemistries, of course, of 15 years, and then there's a mineral oil at the last, right? The mineral oil, which is the base oil, they have a limitations of operating temperatures because they tend to degrade it into a carbonous sludge deposit, and it probably would have a shortest service life as far as heating medium is concerned. So message here is choose the right product. Understand how long you want to operate, how critical is your process, and understanding the process, you select the right chemistry which can work well. And so you don't need to replace at an early stage, which you can wherein you can reduce the downtime of the plant itself. Moving forward, this is like, we'll talk about a bit of system design, how the hot oil system looks like. So you have a fired heater, then you have a pump wherein this hot oil is being pumped to the users, and from users there is a one important component of this system, we call it an expansion tank, right? That's a very, very critical component of the hot oil systems along with the hot oil heater. We'll talk about it, why it is important later. Of course, then in addition to that, there are many components which is being used. We'll not spend much time on it because as a chemical engineer, we know this very well. But what I wanted to highlight at the bottom is there are many codes and standards available for designing a heating system. But I see a little less awareness so far into an Indian market, wherein people are not very much familiar with these design codes like DIN 4754, which is talking about the hot oil system design. So I certainly would encourage all engineers, as and when you design the plant, look at those codes, understand it, and design the system appropriately. See, one of the other important element, and I would say which the most troubleshooting which I would have done in my technical service career of 10 years with an Eastman is the velocities. Industry, I guess we talked about, there's a supply demand always, which is one of the important variable. Sometimes the demand is high and so your plant utilization rate is, let's say, 100%. There is a reduction of utilization rate because demand is down, maybe a 50%. So what we have experienced is during the reduction of the utilization rate, people, or I would say the plant engineers, have reduced the flow rate of the heating system, understanding that they don't need too much of heat output. They can, since the utilization rate is 50%, they can operate the pump at 50% of the flow rate of total flow rate what is being designed for. I would say there are consequences. As far as hot oil heater is concerned, it has to be operated at a full flow. Because if you look at the slide, when you reduce the flow rate, the velocity is reduced, and that would result into one of the other important terminology of hot oil, which is, we call it a film temperature, also called skin temperatures, right? The temperature which is next to the heating coil, which is the first layer where the heat is being, I would say, transferred from a flue gas, then a piping material to the heating medium, right? So that film temperature increases significantly, and that would result into a premature degradations of the oil. And so you will end up having a shortened service life. And these are expensive oils, right? Expensive heating mediums. Having a service life more than 20 years, I would say it's as good as a capital, product. So make sure that you operate it at a required flow rate and don't compromise into the flow rate. There are other ways to save the energies, that I would say reduction of flow rate, but not as far as the hot oil heater is concerned. Now, we are moving into this heating medium. As I said, there is a specific service life which is attached to that product, right? Whatever the chemistry we choose it. And the degradation aspects has a two major element. We call it a thermal degradation, which is basically, I would say, it's a chemistry driven, and the oxidation degradation, which is operation and design driven, right? So we discussed about that expansion tank. That's the only area where there is an exposure of air because it is open to atmosphere at time. And the hot oil, which has operated at a plus 200 degrees C temperatures, and if your expansion tank temperature is greater than 80 to 100 degrees C, the air, I would say the oxygen would come in, and that would react, would result into carbonous deposits as well as weak carboxylic acids. And that acids would increase so-called degradation in a chemistry, I would say in a chemical engineering, a polymerization process, and that polymerization would result into a increased viscosity, carbonous deposits, and would reduce the service life of the product. So oxidation is something which is operational driven, and so one has to be careful with design of the expansion tank. In India, based on my experience, I would say I've seen many chemical plants are still operated without nitrogen blanketing. That's something which I would, I would give a message to all of you that if you happen to see a hotel systems, then of course the one question which you should ask first is your system nitrogen blanketed? Because still there's a notion that nitrogen blanket could be a little dangerous, right? But I don't think so. We must blanket the expansion tank with the nitrogen being an inert gas to make sure that there is no air exposures, and I'm sure that that would help extending the service life of the product. It's not about the service life of the product itself, but as I said, equipment, and you are putting your fired heater also on the risk. Expansion tank, there are many ways to design the expansion tank. And in Indian industries, and I have seen most of the OEMs also, those who are manufacturing fired heater, the expansion tank comes as a standard product. Unfortunately, most of the OEMs have standardized the expansion tank size along with the size of the heater. But if it depends, the expansion tank has to be sized based on the system volume. How much hot oil volume what is the length and what is the height? I guess those are the typical questions, but of course, one of the major, I would say, the reason that it has to be installed at a height is the NPSH requirement. You have your circulation pump, which needs a certain minimum NPSH, and that also, to make sure that that NPSH is taken care, it has to be installed at an adequate height. These are a few types of the expansion tank. I must say there's one of the OEM like Thermax who's been giving this kind of design. You look at on your right, there's a cyclone, we call it a deaerator. So as and when you have a hot oil system, in case air is increased, that air is removed using a deaerators, and there's a line which is going to a next vessel which is empty right now. We call it a blocking vessel, and it is connected at the top, because when your oil is getting expanded, the hot oil is likely to go at the top, because it would be being a hot, it would have a, I would say, lower density, and the cold oil will be settled at the end of that, bottom of the tank would have higher density, and so the blocking vessel bottom is connected to the bottom of the tank to make sure that the tank temperature does not go up. So the critical component is the blocking vessel. So it again has to be sized well, looking at your expansion of the oil, right? So these are a few engineerings which industry at times misses, because you keep expanding and don't change your expansion tank, result into so much of oxidations and premature failure of the hot oil. One more, I would say, German so-called Konus design. The principle will remain same. This design is pretty popular in India. We call it a deaerator buffer tank. And the engineering point of view, you can see H1 and H2 on your left and right in the figure, H1, which is a cold lake, because the temperature is likely to be around 80 degrees C in the expansion vessel. And on your right, H2, where it is corrected to a written temperature, so the density is going to be low. And according to the density difference, that column, liquid column will rise. And if your height, so-called delta H, is not sufficient, you will end up having a higher temperature in the expansion vessel, and so the oxidation will take place, right? So these are a few engineering aspects which industry at times misses, and I must say that as an educational platform, I must say I highlight that you please look into those aspects to make sure that we have a adequate service life of the product. We don't end up having a premature oxidation degradation as far as hot oil is concerned. Few standards available, but I would say I have seen hardly OEM follows it. But yes, everything is available as far as DIN 4754 is concerned. Now, the other important aspects is the thermal degradations, right? So thermal degradation would have two types of degradation. We call it low boilers and high boilers. Low boilers is by definition is the volatiles, as and when you are heating the product, some degradation is likely to happen, because based on the chemistry, and degradation is a function of time and temperatures, right? As your temperature is high, the degradation is likely to be high, right? It would either be in the form of low boilers or so-called low volatiles, or in the form of high boilers, right? Low volatile is something, by definition, being a low boilers would have a less boiling point, so easy to get vented off from the expansion vessel, and that's also one of the important mean of the expansion vessel, that it works as a function, I would say, as a provision to get those vented or so-called low boilers out of the systems. Otherwise, being a low boiler, it would increase the vapor pressure and pump would cavitate, result into a low flow, and your again flow rate would be at the risk. High boiler, by definition, it's a polymerized compound which is accumulating year over year, and that would result into an end of service life, right? As far as the code is concerned, as and when those high boilers reaches to a 10%, fluid should be replaced, right? I'll explain you in the next slide why it should be replaced at a 10%, but just to, again, looking at the slides, there's a GC chart which I've given. Hot oil doesn't have a unique boiling point. Hot oil is a mixture of many components into it, and it has a boiling range, right? And the boiling range starts with the initial boiling point and ends with the final boiling point, and we measure the degradations, one which is within the boiling range and outside of the boiling range. If you understand a GC, on your left what you see, let me see if there's a pointer. Yeah. You see, these are a low boiler compound, because that would, this is a volatile, and then here whatever you see which is getting developed over the period of time here, it would be a high boilers, right? And why this high boiler is in a way important to measure it, because degradation is exponential. Up to 10%, the degradation is linear, but as soon as you touch to the point of 10%, the degradation type changes and it becomes exponential in nature. And so you see the product would degrade very rapidly into a very, very high viscosity in such a short time. Maybe you have taken 22 years to come to a 10%, wherein your viscosity would be, let's say, 60 to 70 CST. It wouldn't take more than a month or 3 months to touch to 300 CST, wherein product would not be even pumpable. Right? And so one has to be a little careful with, make sure that we monitor those high boilers very well. As I said, degradation is a function of time and temperature, and at the same time, it's a function of chemistry as well. Right? Various chemistries have different degradation rates, and so a different service life of the product. This is just to give you a little bit of idea that these are the temperatures and this is the degradation rate. You see these are mineral oils, then there is a alkylated aromatics, there is a partially hydrogenated terphenyl. So you choose a product, and so you get a better service life of the product. Monitoring is important, right? And so there's no as such policy as a country, but as far as state is concerned, every state has their factory act, and within the factory act it is being mentioned that whatever the hot oil you use, it has to be tested and certified by either a manufacturer or a NABL certified laboratory or a chartered engineer, right? Either of these, a lab or a chartered engineer has to certify to make sure that it is in a healthy condition, right? So you have to monitor this by testing this product on a quarterly basis. There are a few parameters like a flash point, acidity, viscosity, high boilers, water content, and insoluble solids. There are ash content, and there are carbon residues as well. A few people measure this. So these are a few testing parameters which one has to be careful with. As and when you draw the sample, you send it to the lab or a manufacturers, get it tested, make sure that those parameters are within the limit value. Each parameter has certain in-service limit value. As far as it remains in a limit value, the product is in good state. And if those parameters are deviating, then maybe as we go to the doctor looking at your blood report, you probably have to take some medicine which is either prescribed by your manufacturer or a chartered engineer. It is as good as that. What is the interpretation of these parameters? Let me explain. Okay, I'm also fine. 2 minutes. All these parameters have certain implications on the service life of the product, right? As well as the operations of the heat transfer fluid systems, right? Flashpoint, of course, the safety risk. If it reduces significantly, then if at all any leakage is taking place, you have to be extremely careful how to deal with it. Neutralization number, acidity is basically probably it would result into an oxidation, and you can have, if at all any extra moisture content will go, maybe you will end up having the corrosions, right? So all these parameters have the certain implications. One has to understand how it will behave if it will deviate out of their normal limit values. So as a conclusion, make sure that you choose the right product and you have the right system design, and of course prevent oxygens and make sure that you get your system blanketed, get your fluid samples regularly, analyzed it and maintain within the limit values. And at the last, I must say that the venting is important. Low boilers has to be taken out, else it will accumulate and it would impose the safety risk as well as the operational risk at the plant. So these are the few takeaways one has to take it back to make sure that your hot oil system is running healthy. Any questions? Happy to take it. I'm at the end of the presentation. Thank you so much. Any questions? I would be happy to take it.
Thank you, Chirag. It was a very good presentation. I just wanted a small question. You said about that the consumers like us, heating industry, we don't have the knowledge of the standards of the terminal, this thing. And you specifically mentioned about DIN standards, which is a German standard. But here in India, it is mostly American standards. Whether you have an equivalence of that, maybe that will be better. Then you can approach the Indian industry. They understand better the American standards than the DIN.
Yeah, sure. I'll take it forward with that body in case, yes. Thank you.
I have a question.
Please.
Short question about this PET processes which you are going online soon, you mentioned. Is it the methanolysis or is it the glycolysis?
We are currently have glycolysis already operational. We are building the methanolysis plant in US. The plant will be operational by next year.
What is the segregation pattern for the PET bottles for that? How do you do that? I mean, in India it's not possible. But in the US, how do you do the segregation of the bottles? You don't need.
No, there are, we have tied up with a few bodies for that, for the collections of the waste, but maybe I would say I wouldn't be a very, very right person for that. If you have any question, I'll make sure that you get your answer back.
Thank you.
Yeah, thank you. Thank you so much.
So I request Butalaji to come up on stage.
I could not attend fully. I was busy with sponsor of war. It's fine.
Thank you, sir.
Now we'll have the next speaker. It is my pleasure to announce the name of Professor Vinay Srivastav, past president, and the instrumental for bringing the Chemcon to Kanpur. He will be presenting the Lab Indians Padma Bhushan R. Kumar Chemcon Distinguished Speaker Award Lecture.
पीछे करो पीछे पीछे कर तो आगे जा रहा है। Yes, yes, please. Thank you. Thank you, sir. Well, like a teacher, I don't want to stick here, static
So before
here
you can
and then
go
want
on,
to
let me just introduce yourself, please.
Okay,
Yeah,
please.
this, Professor Vinay Srivastav from HBTI. A chemical engineer from 1974, the master's also from HBTI in chemical engineering in 76, and then he moved on to Mumbai and he joined BARC, that is Bhabha Atomic Research Center. He was the Department of Atomic Energy as Grade A Scientific Officer Research and Development R&D, Design and Development D&D of lithium isotopic separation from pilot scale to semi-commercial demonstration scale at BARC, Mumbai. R&D and design development of thermal and nuclear-based desalination system from pilot scale to semi-commercial scale on multi-stage flash, multi-effect distillation, and low-temperature evaporation was his forte. Professor Srivastav, please.
Thank you, Vishwanathji. I think, like you, many of you here sitting, must be doing experiment, probably seeing more from a close eyes. And also some of you may be thinking like what happened yesterday, that can a speaker speak more efficiently when the slides are not there? Because when slides are there, you are limited with the slides. Now, being a teacher, I always say that I know all of you are very important persons sitting here, giving your time, and at the same time, you remain connected with your friends and family through mobiles. But often have been told many times that sailing in two boats is not safe, it is risky, not good. Anyway, I probably just trying to say something which may not be looking good at this juncture, but yes, thanks for that. And just like my first slide is just my humble respect to the gentleman, Padma Bhushan, Professor R. Kumar, and who happened to be chairman of RAB committee, RAG Recruitment and Assessment Board of CSIR. And I used to be one expert member in that committee. So just thanks that probably the organizing committee, award committee thought me probably suitable for this, and I'm thankful to my award committee. And also my sincere regards to gentleman Professor R. Kumar. Well, I think So many things are there associated with this college. And I can say, as you can just see, this is my photo at about nearly 30, 35 years ago. Seriously, scientist looking probably, yeah. And then when I moved to, again, back to the academics after leaving academics in 76, it was like probably going back to the college and imbibing you. Some teacher was there in you, so you thought probably you can do some more things, still left over, and your 4 decades of experience in the industry can be shared with the students that way. So I went back. So what you see here, I would like to dedicate this lecture to all my teachers, certainly, because I am in my alma mater here. But one particular teacher I remember at this juncture, and none other than that Professor R.P. Singh, who later on became director of this institute. But he taught me thermodynamics that time when I was in MTech in 75, 76. Why I remember him? That he used to say, even if one student is there in the class, I will continue. And that's the spirit, not looking at who are sitting probably. He was so dedicated a teacher, and that he said, doesn't matter, if at least one is there who is listening to me. So that is what he was. And now coming back to my topic, because time is going. So I will just take from small phrase what we say, Chiti jal pavak gagan samira, tase bana ye mano sarira. Most of us in human being, contains about 60 to 70% water. But it's not an interactive class where I can ask probably, but what I will say, do you know the TDS value of the water inside you? Probably some of you may say yes, some of you say no. Do you know the TDS value of the water being used for making superpower or super thermal power stations? What is the TDS value of water which is being used for making steam? Some of you may be knowing, but many may not. Do you know the do you know the TDS value of the water here, what we are drinking every now and then? Probably some of you may be knowing, but many of you may not. Do you know the TDS value of injectable grade water that we normally take some time? Do you know the value of what we use in electronic and nuclear industries for washing our components? TDS value of that. Wide variety of application, leave apart horticulture, irrigation that we do in our water applications, apart from drinking, in industrial application, food and pharma industries. I'm sure water being so simple, by name we know, we think probably we know everything, but probably like me, when I started working on this topic about 2.5 decades now I work, but still feel I do not know all about water. I'm sure in my whole journey of today's presentation, there is no outline, there is no conclusion. Probably what you see, desalination, the word which many of you must have heard in some way or the other. Many people through films, by Hema Malini and many more, reverse osmosis is the best way to get potable water in your home. No. Then the challenges involved in implementing or in adoption for these technologies to resource augmentation. And keeping in this, I prepared few slides which are large in number though, but I thought probably it is a more focus for my students. But I know here many people who are there having they are not only, they are very much aware, very much awakened, they know a lot of industrial experience, but I'm sure there will be something to carry probably from my presentation when you go out. You must have seen very nice presentation, would mimics in that, but mine is very old, which has seen the era of transformation starting from blackboard to whiteboard to OHP system to now LCD projector. So, but some of the slides may look like a brown paper of a teacher coming to take your class. Oh sir, 20 साल पुराने से पढ़ा रहे हैं. But no, that had something very fundamental, scientific, and it has not changed by time. Only paper got a little more color, that's all. So let's move ahead as the time is moving. I think this is already given in your booklet. Only thing here I am trying to say, challenges are there in every walks of life. And I'll try to make the clarity. Desalination has been there, it is in the nature, it has been there in many of you and me in say plants and animals. but probably we have not seen it from that angle. People have seen desalination only a seawater reverse osmosis plant, that's all. Let us see, we can give you some clarity on that. Now here is probably one field when I joined Atomic Energy, the red one is the more focus, saying that it was on water security and the safety I worked a little bit. And in addition to that, energy security, health security, food security, environmental security, country security, they have been there a part of, say, integral part of my DAE system of working. But I got an opportunity to work on water security and safety and a little more, but there's other things we are not going to talk here. At the bottom, I have just written here one line that India in the category of stress country, what does it mean? Okay, so let me just take the next slide. Here you can see, this shows that whenever a water availability, which because of increase in the population, is going below 1,000 cubic meters per person per year, then it becomes in the category of water scarce. But if it is something in the range of 2,000 cubic meter per person per year and more than that, then it is not water stress. But if we are in between 1,000 to 2,000, we are in stress zone. And that is where you can see the year-wise, based on the population, 51, we were very comfortable, we were having 5,177, but by year 2003, we had only 1,500, and that we became 20% deficient. And now we expect that by year 2025, it is going to increase further, 33% deficient, and this is where the role of desalination and whatever the example just now I have told to you, there is there in one way or the other, not only for your drinking water needs, but many of your industrial needs, even say ultra pure waters, etc. It is there very much. Here you can see just an example, statistical. My whole presentation is there in very informative manner. You don't have to put much mind on that. So some deficiency is always there in a big district that you see, and to meet those needs, it is growing and growing and growing. Even in India as well, in the last, I can say, throughout the world, as on today, 17 billion liters, 17 billion gallons of water is being produced through desalination. And India is no exception now as on today. And we expect by 2025, more than 500 installations of small to big, more than 100 meter cube per day is going to be there, helping to augment our resources. Here you can see that although we have got many rivers, we are rich in that, we have got very good rains, but in spite of that, whenever we try to connect rivers, trying to augment our resources for water needs, these things just try to compare statistically and cost-wise. As you can see, for seawater desalination, I mean, it is 14.5, just for 1 million gallon, there's a very specific cost requirements. And as you can see from various supplies, 12.5. So 14.5 and 12.5 is not very far off. Now it is catching up. But whenever we try to transfer a source from one location to other location, a lot of social problems and fights starts happening, which is not to be told here. Karnataka, Maharashtra, or Tamil Nadu, and all those things have been happening. So it is good to have a desalination plant in local areas or maybe in a centralized facility and see that no fight. Okay. So as you can see, this is how we started in the form of, then Dr. Sarabhai was the chairman of Atomic Energy, in the form of nuclear powered aerodiesel complex, where desalination was one aspect to be dealt with, and saying that you can take seawater, think of a dual purpose nuclear power plants, producing energy and also producing desalted water, and then using them for various purposes. And as you can see, the power can go for making many chemicals that we all need, including fertilizers, metallurgical needs, and chemical industry. And at the same time, desalted water can go to irrigation, and finally you get end products like food and many fertilizers, etc. And in a way, it will help you in getting the good food production, which is also required for our countrymen. So this was basically that time when you look, our Lal Bahadur Shastri ji was Prime Minister here, and he wanted every national laboratory should help and stop getting the imports of PL48, that wheat that we are trying to get it, and help in boosting the agriculture as a productions in the country. And this was the one theme, about 300 pages book is there, and we all are working still on that, which was dreamed by Dr. Sarabhai that time. Next, you can see just a small glimpse of my center, and here it is a left side is the Dhruva reactor, right is Cyrus reactor, big jetty of 1.6 kilometers there. Behind is our Elephanta cave, and on the right, one building seems to be there, one small rectangular building. That is where most of our R&D experiments have been conducted, taking the seawater from the jetty, and then that it became from concept to commissioning, from small pilot scale to large commercial scale plant, which has been developed by us. Now, you can see here, these are the various developments. I must tell you, particularly for those who are students, that nothing just starts from lab scale or say bench scale to pilot scale to semi-commercial scale, then commercial scale. There are stages of development. You just think not that the state way will go to the commercial. Is very rarely it happens. So these are the various stages we started, as you can see, both in thermal technologies as well as in membrane technology, and finally we have making is our purpose is to design and develop, research and develop, promote, and also implement, rather deploy these technologies to augment the water resources within the country and help to the government of India. Here, these are the locations of the various installations that we have tried to give you. I'll try to give you some glimpse of that. That is in the whole India map that we are trying to do. There are various technologies, reverse osmosis technology, seawater technology, brackish water, and using effluents, etc., etc. And we'll see in the given time of half an hour how much I can share with you. Here is just, again, this is a prepare for when I'm taking a class in IIT Bombay, that you have to start with the science, you cannot give up science. You have to you have to understand good engineering, add both to get a good technology, maybe bench scale, lab scale, then pilot scale, commercial scale, but at the same time, you must also try to understand the rules and regulation of the local bodies, corporations, and the government, state, as well as central. Then only probably you can implement the things from concept to the commissioning. Otherwise, probably you may find some hurdles in the between. So here, as you can see here, there's a various regulatory bodies, starting from MOEF and various things are there. I try to list down, because many of our students, I was also not exposed to when I was here in the college doing my BTech and MTech. But now Ministry of Water Resource like Jal Shakti Mantralaya is there, very much seen, looking raw, but as you can see, small by National Water Mission, Water Supply and Sewerage Board, River Development and Ganga Rejuvenation, and many more such things are there. They're all trying to help to augment the water resource and also see which way and which technology will fit in better. You may think probably why I'm being in space or atomic energy, why I did this, but our motive has been there to develop the things for submarines and ships and also for a space mission. But this is something in a spin-off technologies, and also to use them for radioactive waste and how to deal with the waste, radioactive waste. But this is spin-off technology which can be used by the general public or even anybody. Here it is just, I can say, little back, if we think of, we were not thinking much about the water. But now many think tanks are there. We try to do so many ways here and there. Only thing is, things are changing. We are thinking and talking about water. And here is just only on the right shown the number of think tank that is available, and Government of India is doing many ways how we can solve typical various problems, not only related with many other difficult, complex problems, but also are related with the water. So I can say, yes, things are changing. In the last few years, it has already changed. Let us be a part of change and accept that water is also very important to us. Let us not think low about that. Here, I must say, I had bought one book in my first year of engineering, Cinco Plane physical chemistry book. When I was trying to understand the science of water, I didn't know that water molecules doesn't move alone like lion. It always move in the crystal, or say in the group of 5. And it is because of its polarity nature, as you can see on the right side. And when this enters into the membrane, it is having different configuration. When it is in the ice form, it is different. When it is a liquid form, it is different. And many ways that way it is happening. Again, I had to look back my book, which I bought in year 70, 71. And this thing, that time I didn't read, probably it was not, I have to appear for examination and get my marks and grades. But then when I started working on water, I have to look into those science related with the water. Here, you see crystal structures of the water structure and the ice structure is different. That's how we say ice density is lower than that. I could not understand that time, but now I am sure how it works. Here is something, very interesting fact. This whole thing of water chemistry given by Dr. Sauri Rajan, this is taken out from his workshop note, that when we see the water at the sea, the top layer of the water is the pure water. Can you imagine? But it is pure water. It is a film theory, and the interfacial water which is there pure cannot be just taken out like top milk on the malai on the milk. But to get that, you have to do more so that you can make that thin layer of pure water on the top of it little more thicker, and then you can extract. That we did it later on with so many synthetic polymers we developed through membranes and went ahead for making a reverse osmosis techniques for that purpose. So this is trying to show this want of equations. I mean, I don't want to take you like yesterday Professor Sharma has shown you complex equations here and there. Nothing like that. So here is trying to show that as you go deeper down in a vertical way, the concentration of TDS values changes, but the top layer is ultra pure water. That is what it's trying to show. Again, this is something probably you may not have come across. Many of you know probably if water pH is 7, it is a neutral. If it is above, it is alkaline. If it is below, it is acidic. But no, there is a LSI index which is there, which is normally being used more than pHs values, and so range of the pH decides whether water is corrosive or water is scaling. So that is what is trying to show through LSIs, Reznor index, stiff and saturation index, and like that, and also marble old tests when we didn't have any such technologies or laboratory instruments for knowing the pH, then we have been trying to do and use water for different purposes. I will not go detail because it is just a definition, pH minus pHs. The pHs is basically a saturation value of pH. That is basically means water is having so much of say ability to absorb many things, and then when it becomes saturated, it cannot absorb any more or anything. That is the value of pHs. That is again. So it is not only pH. It defines the Reznor index or maybe LSI index that will decide whether water is corrosive or water is scaling. This is something, when we go to the membrane technologies, and this is again I have taken from Dr. Sauri Rajan's workshop lectures, that if you know membrane materials for some time, like cellulose state blend, polyamide at the interface values, then methodology like tubular sheet plate and spiral type or hollow fine fiber tubular configurations, or a transport, how basically transport happens across the membrane. If you understood these three, membrane materials, membrane morphology and membrane transport, and then probably you understood all of the membrane science and technology. Probably this is just a beginning of that, what he said in a very humble way, and he said if you have done, this is one small thing just to make on the transport, probably you must have seen it. So this is basically a preferential absorption capillary flow mechanism which decides about how the separations takes place. This is basically, you can see the membrane, the bottom. The 2T is the pore diameter of the say membranes, and if the thickness of the pure water layer is a T, if all the pore on the membrane surface is 2T, then probably 100% separation is possible under those conditions. But this doesn't happen. When we cast the membrane, some are having lower pores, some are having higher pores. Higher pores decide you higher flux, lower pore decide you higher sharp rejection, and that moves on and moves on. The whole gamut of membrane technology goes on and goes on. So like that, this is a preferential absorption capillary flow. This is a solution diffusion model, and this is trying to only this equation I have brought in the slides, showing that how this membrane constant and how this water transport takes place across the membrane, showing membrane constant, the operating parameter and the osmotic parameter of the solution across the membrane at the feed side and all those things. The whole one slide I can speak for half an hour. But here is not that time neither required, not always. So I'll just continue to go little fast in a fast mode. Next one is basically trying to show the various desalination techniques, and these are listed here: thermal, reverse osmosis, freezing, hybridization, cogeneration, etc., etc. And moving on that is basically this ion exchange is also desalination techniques, chemical desalination, distillation, membrane desalination, and freeze. And often we go with the hybrid desalination, means mixture of two desalination process to get our end products. And then here, looking at the feed salinity, which desalination process is more suitable for that, that I have tried to list down here: ion exchange, electrolysis, reversal, brackish water RO, seawater RO, and distillation, depending upon the feed water salinity, how it goes. This is a list of various unit operations that we must have read or trying to read in our colleges, but in distillation and reverse osmosis, there are two major desalination processes. But when we make a flow diagram, other unit operations also come to our rescue, then only we can make the total things to happen. Here, as you can see, in a desalination, normally we make this general diagram, block, energy coming, saline water coming, you get two streams, product and rejects, and processes could be either way. So when we get two streams, how much maximum recovery you can have, it is also in unity that we need to optimize in every process and that we try to. The various sources that we are having: surface, groundwater, effluent water and seawater, and then various application, the ranges of they have been classified, and then various applications, as you can see. Based on this, we try to put it the way how we can choose the right membrane for right purposes as far as the membranes are concerned. And this is how the mechanism has been shown in many books and many lectures. So I will not try to explain them, go quickly. And these are the various polymeric materials which has been used for making our membranes, which you can see in different categories: for macron filtration, for ultrafiltration, nanofiltration, and reverse osmosis. And then, as you can see, how it looks like that symmetric membrane, how it looks like this, and then this is an asymmetric membrane, how it looks like when you look at the structure part of it. Then again asymmetric membrane. Then here, how the machines and different processes are there, like phase inversion techniques, and how we try to make membranes in our laboratories. This is another dip coating technique. This is again like interfacial polymerization techniques. Here is the actual test cell that normally before we use them in a bigger plant is a test cell used for characterizing the membrane in the laboratories, which often I tell to my students how to do it. This is basically a bigger machine to cast the membrane in our laboratories. This is what we did it in our BRC. This is different configurations that we developed, like plate and frame, spiral, and then plate and there's a tubular type and hollow fine fiber type. And here what you can see in module preparation, other than what we have seen, these are the various components need to be seen and optimized in a very fine way, then only things move better. Okay, there's like Victaulic coupling and pressure vessel, and so many things are there, and that every component has to be optimized. This is the something when I compare all the four configuration, as you can see that maximum plus which is shown for a spiral type. So 99% of industrial applications are now tending towards that, but it's not so others are not having application. They are having specific application that I have tried to show in this slide. This is something to do in a casting room. It's not like that. When I was trying to do, it requires a different conditions. Then only you can do a very good membrane, almost like a green room for doing any operation. Here, how a membrane, when it is made for commercial application, it looks like that. It is so many conditions are there under which only you can use the application. You have to understand them very, very nicely, then only you can use them for any design purpose. Otherwise, you cannot. You'll do mistakes. This is something to do with the thermal desalination. We started with 15, 425, and 4000. And as you can see, the largest scale